color out of this my cat dictionary in order to get my cat has gray fur. So this is the way that you typically use a dictionary. You typically use its key to get the value that's associated with the key, and this allows you to organize your data with a little bit more than just a list of items. Okay, so here we have a dictionary to get the value that's associated with the key.
Sorry about that.
This allows you to work. No problem. Well, we could play it back one more time. No, so here, this is a dictionary that indicates that it's not necessary to use only strings as keys. Really, you could also use integers or other items, okay? And this is a dictionary that they decided to store into the ever ubiquitous Python spam variable. But in this case, the key is actually a number, and then the value is luggage combination. And here the key is 42, and the value is the answer. This is just a way of demonstrating that the keys can be integers or other Python types. They don't have to be just strings. So one of the key things that's different between a dictionary and a list, apart from the key and the value, is that dictionaries don't have ordering. So in a list, you can talk about the first thing in the list. In a dictionary, even though in this case, this dictionary eggs seems to have a key value pair named with the value of Sophie, this is not actually the first element in the dictionary, because there is no first element in the dictionary. Dictionaries, the only way you reference the elements are by their name. So you can't say the first thing in the dictionary and reliably get back any one of these key value items. Now you might get something back, but the point is that dictionaries don't have an ordering. They are labeled values. And so when you use a dictionary, you really don't want to use a dictionary for anything where the position in the dictionary is incredibly important. Okay, you would use it for perhaps, say, a record of a user. And the user might have a name, and the user might have other various items that are associated with it, and then that way you could pull those values back out. But you don't actually do things like give me the first field off of user, because there is no natural first field in a dictionary. Even if you specify these key value pairs in a particular order, they will not be stored in that order, and that order will not be captured and retained. Now, since they are not ordered, the entire idea of slicing them or selecting out a sub-range of elements in the dictionary doesn't make any sense at all, because if they don't have a consistent ordering, then any sub-ordering certainly wouldn't be consistent and wouldn't make any sense. Now, what they do have, though, is that you can get an error. Who has already, using the list tutorial of Evan, accessed something that wasn't in your list? Okay, I see a few hands. This is a very common thing that will happen, and it's part of just practicing programming. In a dictionary, it's possible that you access a key that is not in the dictionary. This is the dictionary's analog to index out of range on lists. And so here, we see that they use this spam variable, and they basically say that the name has a value of Sophie and the age has a value of 7, and then they say, what is the key, the value for the color in this spam dictionary? And if you see that it hasn't an entry for color at all. And so it will come back and it will basically say that there is a key error, and it will tell you the key that doesn't exist, the one that you asked for. And this is useful for debugging purposes. You can then go and take a look for the key that you're pulling out, and you can determine why it's not inside the dictionary. So the ability of using these keys allows you to use words that you would normally pick in order to organize your data in useful ways. And we will see a couple of different useful ways a little bit later in this presentation. But here you can see that this is a dictionary that has decided to take first names and map them to string representation of dates. And so when you do this, this is a relationship between every entry to a value. Oftentimes, it's useful to store that relationship inside a variable that makes the relationship slightly more clear. So as before, we were talking about cats, and we were talking about cats and their size, color, and disposition, and this makes it clear that this has something to do with a cat. Down here, when we're talking about birthdays, we're actually storing different people and their birthdays. Alice would have a birthday of April 1st, whereas Bob would have December 12th. So, who has actually looked at the birthdays.py file or typed it in or tried to use it? Okay, I see a few brave hands. Basically, what this did was this asked you for a name. And if you didn't input a name, then it basically broke out of the while loop. Remember the flow control that we talked about 2 lessons back. But if the name was inside the birthdays dictionary, then it printed out the name, okay? I'm sorry, then it printed out the value stored under that name is the birthday of, and then it printed out the name that you inputted. So if you basically had an input of Alice, Bob, or Carol, then this if name in birthdays would render true because there is a key inside the birthdays dictionary that matches the value that you typed in on the input line. Once it knows that that key is inside the dictionary, then it prints out the value for that key as the birthday of, and then it would print out the key itself. Now, if, for example, you typed in Kevin. Kevin is not in this list. I'm sorry, Kevin is not in this dictionary, so it would say, I do not have birthday information for Kevin. What is their birthday? It would read the birthday value from your input, and it would actually update the birthdays at the new key entry with the birthday that you typed in. One thing that is interesting is that when you do this, any value that was stored at that key previously will be lost. This is not necessarily adding an entry. It might be if the key didn't exist at all. But if you had a person that inputted, say, a new Bob, and you overwrote one Bob's entry with the new Bob's birthday, then the old Bob's birthday would be gone because this would be an update to a key. So this same syntax is used to both add keys and values to dictionaries, and it is used to update values for existent keys. Okay, and so here's an example. We talked our way through the program, so let's see what it looks like when you actually run it. Of course, it asks for that enter a name. You type in Alice. It will find, due to the if statement, that Alice is in birthdays, and it'll print out the value for the Alice key. April 1st is the birthday of, and then it'll print out the name that you provided, Alice, and then it'll say enter a name, and it says Eve. It will say, I do not have birthday information for Eve. What is their birthday? You type in December 5th, and it says that the birthday database is updated. Now this means that now the birthdays dictionary has 4 values instead of the 3 that we originally initialized. So when you type in Eve as the name, it now finds the name Eve inside the keys that are stored in the birthdays dictionary, and so it'll print out the value that you had updated the key Eve to, and it'll say December 5th is the birthday of Eve. And of course, because of the break statement, if you just hit enter and there is no input, then it'll quit.
Is there any way to index a dictionary with the value instead of the key?
you would normally take the values and build another dictionary of keys. It is possible to list every item in a dictionary, but one of the problems with indexing it by values is, let's say that you had 2 people with the birthday December 5th.
Yeah.
If you did that, since the first entry would say December 5th is Eve's birthday, the second entry, if it say happened to be, Frida's birthday, then it would actually update the December 5th entry to be Frida, and you would lose any information about Eve's birthday. So when you're dealing with a dictionary, the keys is a set, okay? But the values does not need to be a set. And so if you take those values and you treat them like a set, you may lose duplicate entries.
Great, thanks.
You're welcome. So now that we've kind of talked a little bit about how to add keys and values to dictionaries, there are a few methods that make it a lot easier to use dictionaries. For example, if you didn't happen to already know the key or query your user for the key, you might want to get a list of all the keys in your dictionary. Or, likewise, if you wanted to check to see if anybody had a birthday of December 5th, you might want a list of all of the values. And sometimes it's useful to work through each entry in a dictionary, one pair of key and value at a time. This is what the keys, values, and item methods do for a dictionary. Keys will return back all of the keys that happen to be in a particular dictionary. Values will return back all of the values, and items will return back a pair of key and value. Okay? I should take that back. It won't return back a pair of key and value. It will return back all of the pairs of keys and values inside the dictionary. So here we are, again, with spam, and we have the key color and the value red, and the key age and the integer value of 42. And so we will say, for V in spam values, print V. Now what this will do is this will ignore the keys that are inside spam, and it will just print out the values. And you see that it prints out red and 42. Now it's pot luck which one comes out first. Sometimes 42 could be the item that comes out first. Sometimes red would be the item that comes out first. This is because dictionaries don't have an implicit ordering. There is no ordering inside the dictionary. If you type this program in and you run it, you will probably see the same ordering come out again and again for your run of the program. There is no guarantee that that ordering will be stable over time. So you really should not depend upon ordering inside dictionaries. If it's incredibly important that your ordering be a particular way, either sort the items after you pull them out of the dictionary, or maintain a list of the key order that you want and pull them out one at a time. So likewise, we just talked about the values. Let's move on to the keys. So here we are, we've got a for loop, and we're going to go over all of the keys in the spam dictionary. Here we get color and age. Now these happen to be in the same order as above, but you shouldn't encode an assumption that if you pull out one order using keys, that you get the same ordering using values. These kinds of assumptions are the kinds of things that will bite you eventually. And here we get items. And items, again, will give us our list of pairs. And so here we've got color, which would be the key, is mapped to red, and age is mapped to 42. These will come back with small, with basically a list of all of the different items in the dictionary by key and value. And the keys will be separated from the values by a comma. Okay? So far, do we have any questions about dictionaries? Yes?
In this case, what's the difference between the dictionary spam and spam.items? How is that just formatted differently?
So one thing that's different about it is that span.items is an array of basically what will be called tuples. Okay? And so it's an array of things. You cannot use this array of tuples like a dictionary. So if you say keys on this array of tuples, it won't know what you're talking about because you're dealing with an array. You're not dealing with a dictionary, and so the keys function won't work on it correctly. So there is a difference, but the difference is mostly what type of data that you're working with. Not necessarily the values that are stored as the keys or the values inside the dictionary, but the way in which they're structured. Yes?
Could you detail more about the data types, dict underscore keys, dict underscore values? Like, is that saying, like, that, what's it mean? What does it mean by that?
Okay, so let me see if I can go ahead and try to illustrate it with a drawing. Do you have an eraser?
They're on the board.
Oh, thank you.
Should you erase the password?
Oh, I see. Thanks.
All right. Looks like project names to me. So, when you're dealing with an array, and this is an array of strings, when you want to pull an element out of this array, you would say something like items, and you would do the index offset, which isn't the same thing as first, second, third, but is actually 0th place, 1st place, and 2nd place. Ugh, 2, whatever. So you would say items 2, and this would pull the value 3 out. Okay? Now, if items were a dictionary, then you would have to have a label for these items. Okay? So let's say that the age was 1. Okay? The height was 2. And the, I don't know, color was 3. So when you reference these here, instead of referencing them by their index, because there are no indexes in a dictionary due to the way that it is stored, you would say something like items age. Okay?
And that age is the data type.
The age is the key. And so it will find within this items dictionary the key that matches it, and it will return back the value. So this items age will return back the value 1 as a string. Okay? This can be incredibly useful because as you're trying to program, occasionally you will want labels for the data, and other times you will just indicate that it is one of many. All right? And so if your data naturally needs a label, you probably should reach for a dictionary. If you were going to name this item, it's much harder if you wanted to remember that, say, all ages are at index 2. Instead, just use a dictionary and have an age there. And then that way you could just pull the age out of the dictionary. It also helps if you maintain your software by perhaps adding items. If I were to add, say, instead of just age, height, and color, let's say I added a state to this dictionary for the state that this thing is stored in. And by state, I mean like a geographic state. So we would say state, and then the value would be Texas. All right? Then what would happen is, if I was using an array, it would depend upon where I added the state, how much code I might have to update. If I decided for one reason or another, adding the state at the beginning of the array was a really good thing for my processing, then I might have to do a survey of all of the code that uses that array in order to make sure that all of that code has correct indexes for the other items. Now, if I was using a dictionary, then it wouldn't matter where I had added that state into the dictionary, just as long as I added it correctly as a key with a value. Because dictionaries don't have an implicit ordering. I can't say the second item in the dictionary. I have to say something like the height in the dictionary.
I mean, you could, but I guess you'd have to iterate through it, find out what it is, and then...
No, I would actually have to convert the dictionary to a list. And in that conversion, there's no guarantee that the keys would be read out in any particular order or that the list would come up with that order. So when you run that keys command, you get back a list that looks like age, height, and color.
Right.
Okay? When you run the values, you get back a list that looks like 2, 3, and 1. And when you run the items, you get back a list that looks like age 1, color 3, and continuing down to the next line, height, and I apologize for starting so low on the board, you might not be able to see it in the back, 2.
That's why I get you. Earlier you said if it were important for some reason to maintain that, you'd have to have a list of the keys. And if, for example, if height were important, you always have that, so you could always just refer back to that height key.
Well, you don't have to maintain the list of keys just to access it. But if it was important to access the values in a particular order, then you would have to pull the keys out and use the keys in that order to get the values in that order. Does that make sense?
Yeah, I think.
So like, you know, occasionally for addresses, there's particular formatting. And you want to have like the person's name first, and then the street address, and then like on the bottom line you want to have like, you know, the city, state, and zip code. All right? If you did values, there would be no guarantee that you actually had the name first.
Right.
Okay? So you might want to say either pull it out by hard coding the items that you want to pull out in order for your formatting, or if it was something where you weren't supposed to hard code the items, then you would probably want to keep a list of the correct order to pull them out of.
But if you pull out the keys and you order them in a list, does that mean that the values will stay in that order or next time you go back? Or no?
Yeah, but if you pull the keys out of a dictionary, you're only guaranteed to get all the keys.
Okay.
You're not guaranteed to get them in any specific order.
Right.
So that's what I was trying to get at, is that the dictionaries themselves are unordered. And they're unordered for a very specific reason. It allows you faster access. Yes?
Do the keys have to be strings?
The keys do not have to be strings. They can be integers, they can be other data types. I do not recommend using something like an array as the key, simply because it will look for not the values within it, but the actual array reference.
Yeah.
One more question, if you took the keys out and you had them in a list and you sorted the list, let's say alphabetically or some other way,
Okay.
at least that would be in order, and every time you could use that then to search for a key, and then you'd have to, in your code, use the key to try to get the value, because you wouldn't know the order. But you have an ordered list that you could sort of search, or...
If you had a policy that you wanted to print all the keys out in alphabetical order, then that's exactly what you would do. You would pull out all the keys, you would sort the keys alphabetically, and then for each key, you would display the key and the value.
Okay, got it.
Okay? But that doesn't mean that the dictionary itself
No,
would store it in any
right,
particular
right,
order.
Right.
Okay, so here we are, and you can see that here we've got span keys, and it comes back with basically all of the keys that's inside the dictionary, and you can see that it's wrapped in a little type here. And if we were to take that dict keys, which it, and flatten it to where it was just a list, we would actually just get the actual list values. So this list function right here will take the dict keys value, okay, and it will just basically pass that into a list function, which will return back just a straight list, not a list that's decorated as keys. So you can also use multiple assignment. And multiple assignment allows you to assign two variables in one statement. So remember how we talked about items would return back a bunch of pairs where one of the elements in the pair was the key and the other of the element would be the value? By using this K, V syntax, what will happen is the items which are returning back key value pairs, the key will get assigned to the K variable, while the value will get assigned to the V variable. So using this example here of spam with the color red and age of 42, we're not really sure which one of these will come out of the dictionary first, but inside the processing of this loop, K will be either age when V is 42, or K will be color when V is red. This grouping of key and value is preserved in using items. And even though multiple assignment looks like you're storing two things at once, it's still a structured two things. It's still the key and value. There would never be some sort of a way to get back red as K and age as 42. Dictionaries are not some fancy syntax for lists. Okay, and so here we are, and sure enough, it did print out the age first in this example, and then the color second. All right, so sometimes you've got dictionaries which are very structured. Yes?
Ken, if that little bit you just talked about, the order thing, where if you created a program like that, every time you run it, you'll get the same results, right? It won't like randomly choose which one.
Maybe. When I say it's not guaranteed, I truly mean it's not guaranteed. Okay? It could depend on so many different things that I cannot really say yes or no. And you should not really rely on it.
Right,
Okay? If you happen to run it 30 times and it prints it out in the same order, that 31st time could be the first time that it prints it out in the order you were not expecting. So just when you're using a dictionary, if you need to apply some sort of ordering, just keep in mind that you have to apply the ordering outside of the dictionary. Yes?
Why did we convert the V to string? Is it because of the 42?
Yes. So in this case, if he did not call the string function to convert the V to a string, then he would have gotten an error in this print statement when it processed 42. Now, if you happen to know that all of the values for a particular key are strings, then you probably could have survived without the string function. For example, in his case, he did not put such a protection around the K because it just happens that his dictionary has all strings as keys. But if he truly wanted to be paranoid, he could have also wrapped this because fortunately converting a string to a string returns back the same string you had in the first place. Yes?
Oh, I was just, when we create the dictionary, we have to use a string for the key.
No.
No?
Matter of fact, we covered this previously, and so I'll just go back up and we'll drive it home one more time because it is important to understand this. Your keys are only things that make sense to you while you are deciding how to lay out the dictionary. In this case, this person decided that using numbers as keys made sense. Now, if it were me personally, because I do not have a need to look things up by number very heavily, I probably would have put the luggage combination as the key. But in this case, they have a reason to look things up by number, and so they put the number as the key and then the description of what the number means as the value. Yes?
So can a number and a string with the same both be keys?
Yes, you can have keys as numbers, strings, combinations of numbers and strings, you know. Well, I mean, it would have to be different key entries. You couldn't have one key that actually was both data types.
But you could have a number and a string, and it would be different than the number.
So like right here, they have 1, 2, 3, 4, 5, which is a number, and it's obviously a key because it's to the left of the colon. Over here, they could have had a string 42 instead of a number 42. In this case, he just decided to have a dictionary where all of the keys were numbers. There is no requirement that your key, whatever type you're using for your key, be only that type throughout the whole dictionary. You can have a dictionary that has any kind of type as the key. Okay? It's just very useful to only use types that basically can't be updated. Because you don't want to use a type that can be updated, otherwise it will become nearly impossible to use your program in the long term. Alright, so scrolling back down, we're going to get into just a little bit more of this keys and values, and I know that by the time that we're done, you'll have heard the word key and value approximately 100 times, but that's because you need to know how to use these dictionaries. Because dictionaries can be defined many ways, sometimes you'll have a dictionary and you won't actually know if a key is in it. Okay? And so what you can do is you can basically use an expression where you can say something like, is name, okay, in this case, name in spam keys. Now, keys will return back all of the keys in the dictionary, okay? Name is a value, so this name will be checked against all of the keys in the dictionary, all right? So in this case, name is the first key that's typed on this screen, not the first key in the dictionary, but the first key typed on this screen. So it will return back both age and name will be found in the grouping of both age and name, and that means that this expression will render out to true. Likewise, when you use values and you get back the entire collection of values, you'll get Zophi and the integer 7. Okay, now this is a mixed, grouping of types. So this is a good example of how their typing is not consistent throughout either side of this. Zophi will be found, or the string Zophi will be found as a value somewhere in that dictionary, and it will say, yes, it's there. Now, color, in this case, is not a key found in the dictionary. So this will basically evaluate out to false, and color is Okay, but if you wanted to use the not keyword, you can say color is not in this dictionary. It's a good way of checking to make sure that you don't have something set. Remember how I said that if you set a value in a dictionary through its key, you could overwrite it? Occasionally, you won't want to overwrite it, you know, because it might already have an existing value. This is a good way of checking to see that the key is not already set. You basically say, this key is not in the dictionary's keys. And here you can basically say color in spam. Now, when you do this, this is shorthand notation for color in spam keys. You will see this, but it'll probably be more readable to a lot of people and a little bit easier, a little bit easier to rationalize about the code when you read it later on if you actually go through the extra effort of indicating that you're checking the keys. Okay? But if you decide to not check the keys, then it will actually use the key function implicitly and return back the keys. So you can say something like, you know, name in, you know, a dictionary of perhaps logged in user. Okay? But it would be a little bit more readable for people who maybe don't remember this sort of default behavior if you actually said something like name in logged in user keys. All right. So the get method. So again, we can definitely use this sort of array notation. You know, this notation that looks like it's kind of an array and you're pulling the key out. But due to how dictionaries have been used in other languages and how Python has flexibility in matching syntax that other people have become accustomed to, there is also a get method, which treats the dictionary as the object that it is and will pull out the key. Now, there is one huge advantage to using this get method, and that is that the get method also can provide a default value. So in this case, up here, when they are using the picnic items get, they are saying picnic items get cups, and if cups does not exist, then return back the value of 0. Cups does exist, and it has a value of 2. So in this case, this string that it's building up will be the value of 2, which is an integer, but it is wrapped in a string constructor, and so it will change that 2 to the string of 2, and then it will say, I am bringing 2 cups by combining all of those strings with the string concatenation operator, the plus sign. And so it's, I am bringing plus the string that contains the character 2 plus cups. And you get, I am bringing 2 cups. Now, the point of talking about this is, of course, to illustrate this get function. All right? Here is the same thing, but now we are asking for a key that does not exist. If we had done this with those array bracket notation, as you see here in items age, then what would happen is you would get an error because eggs doesn't exist in the dictionary. And so it would say your attempt to look up eggs failed. You have a missing key. And since we're using the get and it provides this default, what will happen is it will look in the picnic items and it will see that there is no eggs key. So then it will return back the value, the default value that you passed in, which is 0. Then it'll take that 0 integer value, construct a string out of it, and add together, I am bringing the string containing the character 0, eggs. And so this is, I am bringing 0 eggs. So if you're dealing with a dictionary that perhaps is built dynamically, or loaded out of a data source that you don't have complete control of, maybe it's stored in some way in a database or something where it could be changed, then using this get function prevents you from getting errors in your program while it's running, because you can provide a suitable value. Another way of doing this would also to be using an if statement wrapped around the functionality, checking for the key explicitly. But occasionally, the if statements can make the flow of the code harder to read, and you already know what the default should be if it's not there. In this case, if it's a number of picnic items, and no picnic item is inside the picnic items dictionary, it makes perfect sense to say you're bringing none of them. No matter what they are. I mean, you could be bringing 0 airplanes or whatever. You know. So this get function, it can be incredibly useful. It makes your program smaller to read and in some ways easier to reason about. So here we are again, and this is an illustration of what happens when you don't use the get function and you ask for a key that doesn't exist. And you'll see right here that you get a key error exception thrown saying eggs. And the reason it says eggs is because eggs is the key that is not in the picnic items. So this would be an example of how your program would gloriously crash because you pulled a key out that didn't exist. Now, there is a set default method, okay? And set default method is a little bit different than this get method. The get method operated on the key, okay? So set default basically allows you to only add a value if the value was not already set. So occasionally, you want to add a value, but you don't want to overwrite an existing value. For example, let's say that you're Henry Ford and you're producing Model Ts and you can have any color you want as long as it's black. So normally when you build, his famous quote of his, okay? So normally when you're building this Model T, they're not going to put into their Model T database a color value of black for each one because there are no choices. But if one day they decide to expand their Model T, inventory database of produced Model Ts, because they're starting to initially offer new colors, then they will want to add a color value to each entry into each dictionary containing the Model T details. All right? Now, for all of the ones that don't have a color, the previous policy was that the color was black. For all of the ones that do have a color, you don't want to override whatever color it is. So this is where you will use set default. Set default will only set a value if the value does not exist. So here, we are using set default to add a color to the spam dictionary. And since the spam dictionary is lacking a color key, the value black will be stored at the color key in the spam dictionary. Now, it has a side effect. And side effects are basically, ways of saying that it returns back something that you might not have expected but happens to be sometimes useful. In this case, when you call this, not only does it set the value in the dictionary, but it also returns back the value. Occasionally, when you get into more advanced programming, which will come in the later chapters of the book, you'll find that it's useful to capture this value to see if it was truly set. Okay? Here, on the other hand, is a dictionary. Well, actually, it's the same one. Now the value black is under the key color. So if we were to call set default the color to white, you will see that in this case, it returned back black because that is the part that makes it easy to understand whether it really set a default or not. But you'll also notice that if you list out the dictionary, the color was not updated. If you had done something like, say, spam, brackets, quote, color, quote, close bracket, equals white, then you would have definitely overwrote the black value under that key. And when you printed it out later, it would say that the color was white. So set default is really useful when you have a dictionary and you're not sure if it has a value. But if it doesn't have a value for processing later on in your program, you want to make sure that there is at least a value for this key. One that makes sense, hopefully. And this is just going through and describing how the first time there was no color, and so it added it, whereas the second time there was a color, and so it did not add it. Now, if you don't mind, I'm going to sort of take a quick look at where we are, because I know that food has arrived, and let's see how far away we are. Oh, we're almost to pretty printing. So we'll just finish up here with set default, and we'll talk about how it's different than actual assignment, and then we'll take a break before we get to pretty printing and get a little bit of food. So here we have a message, and this message is a string, and what we are going to do is we are going to count each character in the message. Okay? So that means that, remember, strings can be seen as arrays of characters. Python does this naturally. It converts back and forth. There's not a need to concern yourself about it. So what you do is you just say for each, and this is the variable character, which will get initially the letter capital I, and then the letter T, and then the space, and then the W. For each character inside this message, we want to count the character. Now, if we're processing this W, there is not a W inside our count array. I'm sorry, inside our count dictionary. There's no key W. So if we were to immediately assign it, it would be an error. We're looking up a value that doesn't exist. Because here we would be trying to pull out the value and add one to it and then reassign that value back to the key W. So what we want to do is we want to use set default to make sure that inside the dictionary, before we try to update it, it will have a value of 0. This means that when we get down to things like, here's the first letter C, okay, to prevent this line of saying count of C from throwing a key not found exception, we will use this set default. But when we get down to this second letter C, this set default will see that character has a key C. And since it has a key C, it's not going to update it to the value of 0. It will keep it at whatever value that it's at. And this will allow this second line right here, count character, to pull the previous stored value 1 out, add 1 to it, and store that back at the key, which happens to be the letter C. Doing this, we can basically count all of the letters inside this string and store all of the letters inside the dictionary. And so if we print out this dictionary, we will get a large number of keys and values. The space is in there 13 times, a comma is in there once, a period is in there once, the letter C is in there 3 times, and so on. I lied. We'll go through pretty real fast. The difference between this output is that this output goes very far to the right of the screen. And it's all on one very large line. and this can be incredibly difficult to read. Occasionally, it is more useful to read the output in a format that you can scroll up and down. I mean, the reason that we're so used to scrolling up and down is because so many of our things that we use on the computer function more easily by scrolling up and down. We read from top to bottom in English, and computers, due to those biases, tend to scroll from top to bottom. So here, it would be very hard. Matter of fact, you can see that I have to scroll to the side of it just to see some of those elements inside that array. And eventually it wraps, and it's not very pretty. So there is pretty printing, and the only difference between pretty printing, which you get by importing the pretty print module, is that pretty printing will structure your output to where it's a little bit easier on the eyes. You'll be able to tell that your keys come first, your colon, and then your values, and it will try to separate it out in such a way that it is always easy to differentiate the key from the value. If I am somewhere in the middle of this, there is a chance that I don't notice where the commas are, and I mistake a value for a key or a key for a value. With pretty printing, it lists it from top to bottom. And so the way that we do that is, instead of printing out the dictionary, we use the pretty print module and its pprint function, and it will display exactly the same dictionary, but it'll display it in a format that for some is a little bit more pleasing to the eye. Okay, now that's a really good stopping point, because the next time we're going to talk about using dictionaries to actually solve problems. Right now we've gotten an idea of how to use dictionaries in the sense of what function and facilities they provide. But sometimes it's useful to actually use them to solve a problem, because few people are only interested in the functions and facilities that they provide. Most people are interested in solving a real-world problem with them. So let's take a break and get some food. Awesome. Welcome back. Thanks for taking a break for dinner. And now we're getting on to the juicy part of using dictionaries, using them to model real-world things. So by chance, they happened to pick a game that I truly enjoy. And so they're going to talk to you a little bit about the history of chess here. Before the internet existed, people were playing chess remotely. Okay, they would do this through something called correspondence chess. You'd basically write down your move, put it in the mail, wait until you got a reply move. Okay, surprisingly, you know, a lot of the email messages are modeled after the post office, so once correspondence chess became less of a thing to do with real stamps, it became even more of a thing to do with email. Eventually, they did build, you know, chess clients that made life a little bit easier. But the point is that they're telling you about algebraic chess notation, which uses the chessboard as a grid. And you have letters down one side and numbers on the other side. And there's a particular way in which you can write that pieces move. You can say something like pawn to d4, very popular opening, okay? And people would be able to take your little notation and move the pawn to d4 when they got the, you know, the move that you made, and then they would be able to like write down that they would say, oh, okay, knight to f6. And well, you know, there's only one knight that could make it to f6 legally, and you would have to kind of figure that out. But the point is that you can play entire games at a very slow speed through the mail using this algebraic notation. And they're going into some of the details. And this is great, but they're basically saying that, you know, if you got really good at algebraic notation and you had a really good memory, you wouldn't even need the chessboard. You would just simply read through the games and sort of imagine where the pieces were. And believe it or not, if you play enough chess, this is a very natural thing. And so you can read through about 12, 14 moves in an opening and know where the pieces are and just have sort of a visual mental model in your head of where the pieces are. And so what they do is then they keep building this analogy forward and saying that you can play chess without even having a physical chessboard. All you need is a way of representing the chessboard. And then after they go through this wonderful setup of talking about all you really need is a way of representing the chessboard, you don't actually need a real chessboard, they completely change the topic and go to tic-tac-toe. For those of you who'd like to be back on topic, there is a social afterwards, and there will be plenty of chessboards if you're truly that inclined. But a tic-tac-toe board, we all know. Well, maybe we don't all know. So let me draw one real quick. It's possible that someone managed to slip through our school system without playing tic-tac-toe. But that's a tic-tac-toe board. And it's generally played by alternating writing X's and O's until a person manages, through mostly the mistake of the player that they're playing against, to get 3 X's or O's in a row, in which case you then win the game. If, for some reason, you don't get 3 X's or O's and all of the fields inside the tic-tac-toe board are filled up, there is a proper notation for indicating a tie, which is the backwards letter C written over the entire board, and I have absolutely no idea why they decided it had to be backwards. But the point is that in this case, we are going to use a dictionary to model the tic-tac-toe board. This idea of building a structure in your program that is not exactly the same thing as the real-world item, but somehow represents it, is called modeling. And modeling is most of what you do when you are trying to find a way of taking a real-world problem and getting it to where it is managed and possibly solvable, or at least, stored by a computer. So when you do computer programming, you'll often refer to your models as the real-world things, but your models won't actually exist like the real-world things do. If I had a chessboard, I could pick it up, I could wave it around, I could probably break it or something, if I really tried. But the point is that my model, I can't pick it up. I can't wave it around. So in one layer, it's just a representation of the other thing. Okay? It's not actually the same thing as a physical chessboard that has weight and mass. Okay? It is a model of the chessboard. This is important because when you model a problem in a computer, there are things that you will care about, and there are things that you won't care about. For example, if you're modeling a car and all you're really interested in is how many people can fit in the car, your car might be entirely modeled in a map with number of seats. And that's it. Velocity doesn't matter, whether it's got a gas pedal doesn't matter, whether it's got a color doesn't matter, what actual make and unfortunately, I used a really bad word there. What actual make and model doesn't matter. The point is that you're only interested in the number of seats component. So when you're modeling, it's always important to remember the problem that you're modeling and not over-model, whatever it is that you're solving. Because if you write code that doesn't actually help you solve the problem, it just becomes noise in your program. It makes it harder to reason. So we're going to model this tic-tac-toe board. And of course, as a tic-tac-toe board, we have positions for the X's and O's to go into. And it would be useful to know whether or not there is an X or an O there, or if it's an empty position that has not yet been filled. And our model will capture this by basically having the character X, the character O, or the character space as the 3 values that we will store in our model to represent the X, the O, and nothing there. Now, because tic-tac-toe boards are laid out in this grid, we can come up with many different ways of representing this tic-tac-toe board. This is the way that the author decided that he would represent his tic-tac-toe board. He is going to name each one of the positions in the tic-tac-toe board. He's using a naming technique that he has created himself. it's not a standard naming technique, where he's decided to call everything in the top row top hyphen something. And then he's going to use L, M, and R to represent the left, middle, and right columns. Likewise, he'll use mid and low. You can represent your tic-tac-toe board any way that you want, just as long as all of the pieces of your program are in agreement about how your tic-tac-toe board is represented. If, for example, your printing routines sees this as row 1 and you're looking for row 1, you won't find that inside this modeling because this modeling calls it top hyphen something. So he's telling you about how he has modeled his tic-tac-toe board, and this is his model of a tic-tac-toe board that is completely empty, as you would have before you've actually started playing the game of tic-tac-toe. Nobody has made a move here. Top L, top M, and top R are all empty, as is the mid and low values for L, M, and R. So this is how he's thinking about it, and this is how he's coded it into his program. This concept of modeling, it's not important that you get the perfect model when you're learning how to program. It's important that you have a consistent model because your program won't work. But the ability to build really good models depends a lot on what your program does and how fast it needs to run and how easy or hard it needs to be about reasoning about the program. And what you will find out over time is that while most of the time your first initial approach to modeling will not be perfect, but then again, if you remodel it over and over again, your fifth or sixth approach won't be perfect. Eventually, at some point in time, you just stop because it's good enough. And good enough might not sound like that ideal perfect program, but the truth is it's only perfection for a certain kind of use, and a different kind of use might mean that to get that perfection, you'd actually have to undo one of the uses that you've optimized for. And when you do this, then there is no correct answer because it works faster if you lay it out one way and faster if you lay it out another. So this is his board as it is modeled. And this is his board as it's conceptually rendered from the values here. Now he's going to show you basically how he intends to model an X in the center of the board. Here, it's in the mid-M value of the board. And this is conceptually what it would look like. Likewise, here is his board for a scenario where O has managed to win by filling up the entire top row. And this is the matching conceptualization of his board. Now, I want you to notice something. He's using a dictionary, because this is a chapter on dictionaries. And he is laying out his keys in the same way that he conceptually visualizes his board. But the actual storage of these values is not laid out in the way that he's even typed it into his file. So it's important that when he decides to finally write something that will present his board, it's important he pulls the keys out in the correct order. And this sort of alludes a little bit to what you were asking about before. So here we are again with an empty board, and now he's decided that it is time for him to not just have a model of the board, but a visualization of it. He's going to do this visualization by writing a print board function. And so his board will print out the top left first, a dividing bar, the top M, a dividing bar, and then because tic-tac-toe boards typically have a horizontal bar that divides the top row from the middle row, he will go down here and print out this sort of computer representation of a dividing bar using dashes and plus signs, or minus signs and plus signs. And then he'll print out his middle row the dividing line for that, and then finally he'll print out his bottom row. Now that he has defined his print board function, he is going to call it. Because he is starting with a board that representationally looks like the beginning of a tic-tac-toe game in his model, he will get a board that is really badly formatted inside this web page, because web pages eat spaces. But it would look like this. It would have a space, it would have a dividing bar, it would have another space, another dividing bar. On the next row, it would have a hyphen, a plus sign, a hyphen, and a plus sign, and a hyphen. Again, space dividing bar, space dividing bar. In other words, he has come up with the ASCII art version of a tic-tac-toe board. Okay? And that's what his print board function does. And we'll have to bear with the reformatting that my screen is doing on the spaces when we discuss other representations that he prints out of the tic-tac-toe board. So here he is again, and this is that board that is in that winning combination of having the O's across the top row, and then the X's not quite winning. And again, here is the print board definition, the function that is defined. And when we print this board, now you can see that instead of printing these spaces up here, it is printing O, 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 X, X, and X. So he has both a model and a visualization that matches his model in such a way that they both agree. And this agreement of the model and how you view the model is the part that makes your program consistent. So like I said before, it's not always important to get the perfect model, but it is critical to have all of your functions understand the model that you're using and use it appropriately. Okay, now, here we go. Because he's created a data structure to represent his tic-tac-toe board, which he's done in a dictionary, okay, his print board must interpret that data structure in the same way that all of the other pieces of functionality inside the program do. So here we go, let's see. If, for example, he was to leave out the values that had spaces, he simply didn't store a key in value for that. In this case, he would have changed his model to where it doesn't look like this. It would be missing this mid R, low L, and a couple other values. In that case, his print board would not be in agreement about the model because the print board is expecting it, and he would get the error that these keys in his dictionary are missing. Likewise, he could have updated his print board in some way to where if it didn't see the key, it would just assume that there was a space. No correct way to model something, just important to keep it consistent. So now what he's going to do is he's going to basically say, it's time to update our model. And so he's going to say that there are 9 churns in a tic-tac-toe game, and he's going to store into the churn variable the character X. And then he will say, it is the churn for, in this case, capital X, move on which space. He'll ask for which space to move, okay? And then he will store that X into that location. All right? And then he's going to say, if it was X's churn, now it's O's churn. If it was not X's churn, then it is X's churn. And this will flip-flop back between the X and the O, taking turns, typing in which space they intend to move on. After he goes through this, he will, of course, need to print the board, so you get some feedback on the board. Now what this does is this will update his model by putting X's and O's into it. But in this case, because he's capturing the move as the key into the structure, the user will have to know to type in the correct keys. Otherwise, what will happen is he will put in new keys in other locations and the board won't actually update. But he'll be happy to say, well, it was X's turn, so now it's O's. So here we are. Okay, move on which space through documentation or mystical insight. Our user knows to type mid-M and he puts an X on mid-M. Now it's the turn for O, move on which space, and he'll say low L, and lo and behold, the print board function prints the O out. Okay, this is an example of basically how to update the model. Now, you'll notice that in his tic-tac-toe example, the code that we've read so far, it does not detect anything like a winning scenario because his code's incomplete. And he's not going to complete this code in this example because that's not the point. The point is to show how you could use a dictionary to model something and how you could update the model to capture the new state of your game. Okay? Later on, if you're curious, you could take his code, put it into your PyCharm editor, and add some checking for wind conditions, which might initially start looking like if, you know, mid-L, mid-R, and mid-M are all X, then print out X winds and break out of the loop. It'd be a lot of if statements to do it that way, but believe me, a lot of people do wind up doing that because it's just very expedient. There are probably better ways of doing it, but the point is that as long as you are satisfying all of the conditions that are necessary, your program will be functionally correct. If you want functional elegance, you work on it a little bit more and it will be both functionally correct and maybe easier to read or simpler to maintain. So, that pretty much covers the entire modeling thing as he's talking about it. And there's only like one little extra piece right towards the end where he's talking about dictionaries and lists. Now, we talked about dictionaries where things are labeled, and we talked about lists where things are ordered. These are two data types that provide different kinds of functionality. If you need something that's ordered, it needs to be in a list. Whereas if you need something that is maybe structured in some way where you can reference it by its name, it needs to be in a dictionary. You can use dictionaries and lists in combination to have, say, a named item that names a list of items. You simply take the list and store it as the value in the dictionary. And doing this, you can have a dictionary where for one of its keys, the value is a list. Likewise, if you had a list, there's no need for you to store only small things like strings and integers in this list. You could easily take a list and store a large number of dictionaries in it. A good example is, let's say you're, playing around with a toy address book. Okay, address books have names, they have phone numbers, they might even have addresses. Whatever you're going to be putting into the address book, it would be very natural to represent an entry in the address book as a dictionary. You'd have the name, you would have the address, you would have the phone number, email, whatever. Okay, and so you'd have a key, email, a colon, and then a value. Sorry, mirror talking. A key, a colon, and then the value of the email address. The point is that if you have an address book, you don't have just one address in it. You'll probably have multiple addresses in it. And those addresses, it might be nice to actually list them out in a particular order. In which case, you need a list of dictionaries to hold these values. Now, this is not the only way you can model address books. You can model it in many, many other ways. But as a basic sort of first pass, a list of dictionaries might make a suitable model for your address book. Whereas, if you had, say, an entry that was talking about, families that needed to be contacted, and they might have multiple email addresses, then you might have, like, email contact contain a value which is a list of different email addresses. And so in something that would look like that, somewhere inside the dictionary, what did I do? There it is. So here's the dictionary, and it's got all these items in there, and then you would have something like contact, and it would contain a list of values. And so on. And then you would have other entries after it, which would also be key values. The point is that when we said before that you could have numbers as the keys or numbers as the values, that wasn't just strings and numbers. You can have a dictionary as the value and have nested dictionaries. You can have arrays as the value and have arrays nested in dictionaries and vice versa. Yes?
So basically, are you saying that any data type can be unless it's like specialized for one particular purpose, are you saying that any data type can be a value in a dictionary or a list?
Absolutely. Any data type can be a value in a dictionary or a list. So here we have an example of a dictionary that happens to have values which are themselves dictionaries. So here's all guests, and it is a dictionary where the keys are guests. But the values of Alice happens to be a dictionary. And what this is this is a dictionary of his hypothetical picnic outing. And so Alice is going to bring 5 apples and 12 pretzels. And Bob is going to bring 3 ham sandwiches and 2 apples. While Carol will bring 3 cups and 1 apple pie. The point is that you understand through your modeling that these values are the items being brought, represented in a dictionary, with the quantity as the value inside that dictionary. And you understand that the outer dictionary is keyed by the name of the person bringing the items. Doing this, I do not have to change my data structure to bring a new item. If I had structured it differently, then if, for example, Bob decided that he wanted to also bring 3 bananas, all I need to do then is pull the value for Bob, which happens to be a dictionary, and add to that dictionary the key bananas and the value 3. If I had done this in a different way, perhaps using an array where the first item happens to be apples, the second item happens to be pretzels, the third item happened to be ham sandwiches, then adding something like bananas to it would have been very inflexible. And I would have had to go through my entire code base to make sure that adding this extra item in a list didn't mess up the indexes of anything else. That anybody who was looping over it was looping over all of the items and knew how to process bananas as the additional item at the end. Perhaps sometimes people write their loops to where they don't loop over all the items. Perhaps sometimes people write their ways of looking things up as they just happen to know that apple pies is the last item on the list. So they use that -1 indexing to get the last item on the list, in which case that would completely mess up the program. So the point is that it takes a little bit of time to get used to when to naturally reach for a dictionary and when to naturally reach for an array. Whenever position is absolutely important, an array is probably the first data structure you should look at. Whenever the name of something is going to be incredibly useful, then perhaps a dictionary should be the first data structure you reach for. And so here he's going and he's showing how his model of this picnic is going to be used by a function that will allow you to figure out the total number of a particular item that was brought. So here is all of the guests, and here's the item that you're going to look up. And so he starts off with a variable that he declares, saying that the number of them that was brought was 0. And then he says for all of the items in guests, the key will be the guest name. The value will be the dictionary of brought items. Then what we were going to do is we were going to update this number of brought items with the values get of the item. So if he were to say that he wanted to know how many pretzels were bought, it would first perhaps grab Bob and this thing, and because we're using get with the default value, they wouldn't find 0 pretzels there. So we would have 0 pretzels. When it processed Alice, it would include 12 more pretzels. And when it processed Carol, it would include 0 more pretzels. Now, that's not particularly interesting for pretzels because pretzels happens to only be amongst all of these values that happen to also be dictionaries. It's only in there once. So it's real easy to see it's 12 pretzels. But for apples, when it processes Alice, it will add 5. And when it processes Bob, it will add 2. And it doesn't matter which order it processes them in, because it's addition. And 2 plus 5 happens to be the same as 5 plus 2. And so we will get the correct number of items using this for loop here across all of the entries in the all guests. So now he's decided to print out his little table of things that are being brought. And so he says that there will be, this is the string apples. This is just so people can see it on the screen easily. And then he'll use the total brought from all guests of apples, cups, cakes, ham sandwiches, and apple pies. Walking through that, it will collapse all of those values through addition, and it will print out all of these things. Now you'll notice that right here, cakes is not anywhere in this dictionary. It was his decision to use the get with the default that prevented this cakes output from throwing an error. Okay, so remember that those core, just like about 8 different functions that you use with dictionaries, you need to know which one to reach for at the right time. If you're using a representation, a model of your picnic that has gaps in its information. For example, Bob does not clearly specify how many pretzels he's bringing. You know? And it's sort of a gap in Bob's dictionary of things that he's bringing. Then you should use functions that provide some sort of a fallback and default value. Okay? Or you should wrap them in some sort of a thing that says, you know, if Bob brought pretzels, then let's pull out how many pretzels Bob brought. And he says that this seems like a simple model. You know, you might not even need to write a program in order to track 3 people and what they bring to a picnic. And you're probably right if you're only tracking 3 people that are bringing about, you know, at the most 5 different things to a picnic. But the reason that we do computer programming is because this allows us to do things more quickly that we could still do by hand, but the point is it would take longer. It's easy to model it's easy to hand compute what 3 people are bringing to a picnic when they're each bringing 2 different items. It's not so easy to compute what 300,000 people are bringing to a picnic when they're each bringing between 1 and 18 items. Okay? And so by building these models, even though you're maybe building a simple model, there's a chance that your program will grow in a way that's unexpected. And by growing in a way that's unexpected, it might actually be very useful to have some of these functions for very small items around. And that pretty much covers dictionaries. So we'll just go over the very fast questions at the end. And we'll basically open up for any extra questions that maybe didn't get answered about dictionaries. And right now it's 8:12. I'm not really sure we'll be able to get too deep into strings, but we might start it if there's a little bit of time. So, what does the code for an empty dictionary look like? 2 curly brackets. Now I'm going to be, sort of snarky here, and I'm going to present you with a couple of examples of 2 curly brackets, and that way it'll just be easier for you to tell me which ones are yes and which ones are no. So, like that, like that,
Oh.
like that,
Open curly bracket
or
and
like that.
closing curly bracket.
Very good. Open curly brackets and closing curly brackets.
Colon in the middle.
Hmm?
Colon in the middle. There's always 2.
Well, colon separates the key from the value.
But not empty. Okay.
If you actually have an empty one, then there is no key in it, nor is there a value, and the need to put the colon there is not necessary. Okay. What does a dictionary with a value of key, foo, and value 42 look like? And because, it's just so hard to see things that are shouted out, I am again going to convert this into a multiple choice question. Now that we've established that that's the beginning, and what was the key, foo? One of those 2 dictionaries has a key as foo. Which one, the upper or the lower one?
Lower.
Awesome. All right. What's the main difference between a dictionary and a list? Dictionaries.
The order
This is
doesn't
order.
matter in the dictionary.
Exactly.
Order matters.
All right. And also, lists lack something for their values. Keys. Right. So it's not just ordering, but also the ability to name the values. All right. Here is a dictionary. And here's a piece of code. We're going to store this into, say, a dictionary called, stuff. Assuming these 2 lines of code don't have anything special in between it, what would you expect to happen with the second line? Right. You may not remember exactly which error, but it is going to definitely throw an error. It'll tell you key error, because it is a key error. Well, it might not be all capital. I just like making errors really scary because they're bad. And it will tell you something about the key error. What will it tell you? It will tell you the key that threw the error, foo. So it is important to remember that it tells you the key that causes the error. and not the variable that was in there. Now, it'll mention the line number too, and using the line number, you can actually find the variable that was being accessed. But it will tell you which key caused the problem. Okay. If a dictionary is stored in a variable span, what's the difference between the expressions cat and spam keys? Now, this is, in my opinion, an awkwardly worded question. But having read enough of the book, I believe I understand what he was trying to say. So I'm going to try to illustrate it for clarity's sake. All right. What is the difference between, what was the name of the variable? Spam. Somewhere in here, the string cat exists. Okay. And somewhere in spam keys, you know, this will return back a value. Somewhere in there, the string cat exists. And this ... ellipses notation is not valid Python. This is just me saying somewhere in there. What's the difference between this and this? But there is. Because you see, strings inside a dictionary might be keys. They also might be values. So the difference between the string cat being somewhere inside a dictionary is you don't actually know if it's a key or a value. But the string cat being inside that dictionary's keys, you know for a fact that it is a key.
But I thought like the default, you shouldn't specify which one it is. The default is key, isn't it?
No, you have to specify both a key and a value, because you see the value is stored at the location of the key. And so there is no sense in specifying a location when there's nothing to store there. You know. So also, if you had like two keys back to back, then there would be no way of differentiating easily that these are two keys back to back and not a key and a value. Okay, so the point is that this very awkwardly worded question of the difference between cat being somewhere in the dictionary and cat being in the keys is that cat being in the keys, this string is a key. That means that only half of the values in the dictionary, you know, are keys. All right? Now, if a dictionary is stored in spam, what's the difference between the expression cat in the dictionary somewhere and cat in the expression spam values? Exactly. I mean, it's the same question, just worded with the other half of the pair. Now, one thing is that keys, because every key in a dictionary is unique, okay? Because if you reuse a key, then you're just reusing the same location. So if you say cat is a key 5 times, all you're really doing is rewriting that location over and over again. Spam keys will only have the value of cat once, assuming that it's in there at all. All right? But spam values, it could have the value cat in there many times. For example, if it was a dictionary of, say, students at a school and what is their favorite pet, you know, and what is orange and what says meow and things like that, then the word cat might be in there, or the string cat might be in there multiple times under different things. Okay. This code, if color is not in spam, then set spam's color to black. There's a shortcut for this code. Who can recall the function that is the shortcut for this code?
Set default.
Set default, very good. And what is the module that can be used to pretty print dictionary values?
Eprint.
Fantastic. And what's the function under pprint that does this? I know it's pprint, but that's what it is. So fantastic. We have made it through dictionaries, and now there's sort of a practice project area. Is anybody keen on doing the practice projects? Do you have your hardware with you?
Oh, no, but
Okay, reading through the practice projects is not nearly as instructive as actually attempting to perform them.
I mean, if we knew, I would have prepared it.
No problem, no problem. I highly recommend that you take the extra time to try to do some of these practice projects. It will develop your skill with the language, even if you're already an experienced programmer. You know, if you're experienced, great. It's just more practice using the language. If you're not experienced, great. It's more practice using the language, and you know, it's building up some experience. So what this is this is a fantasy game. And as a fantasy game, I think we can read between the lines and say that considering it has ropes, torches, gold coins, and daggers and arrows, it's probably like a Dungeons and Dragons type fantasy game. And so here is the dictionary of perhaps somebody's inventory. And because we've decided to represent somebody's inventory this way, we would like to be able to display it this way and to print out the total number of items. Okay? Again, he's presenting some of the code where he's giving you the display inventory. Item total is 0 for each pair of key and value in the inventory. You're supposed to fill in some sort of code here that would somehow allow you to print out the total number of items. It's pretty easy. If you're doing more than 3 lines of code, you're probably doing a lot more lines of code than's needed. I highly recommend that you give it a shot. And of course, until you call this function, it's not going to display anything. All right. Now, he's going to basically ask for you to add to an inventory particular extra items. And again, we're going to sit here and use an add to inventory. This should update that inventory dictionary with the additional added items. And he's giving you just enough code to where the only thing he really wants you to do is update that inventory dictionary. And that pretty much covers the, sort of like the little bonus game inventory practice project. So if you run into any problems on that, and you happen to have your code with you and your hardware with you, and you want to present them, we'll give a little bit of time at the end of this presentation in order to go through and make sure that you've got a good grasp on it. And if you don't have your hardware with you, that's fine. You can definitely reach out to us in the Discord chat channels with your questions, and we will definitely address them and help you out as need be there. Okay, so that covers dictionaries. We have a very short amount of time for manipulating strings. If we start into it, we probably won't really get to any good stopping point. And so these chapters are larger than the chapters that we've had in some of the classes in the past. And so I'm going to actually cut it off here a little bit early tonight because that way covering one chapter at a time, it just makes more sense structurally. So thank you very much. And
Thank you.
That's it.
One of the lectures I listen to, they always have clapping at the end.
Awesome.
You know what?
Okay.
That was a lot of homework on your part.